here. So I will upload lectures from the review here as well. The sample test. This sample test is, I'm going to leave this up. It's not due for a grade. I'm going to leave it up for the rest of the semester. But this is just the mechanism of how the test is going to work. Your test is going to look like this too. It's going to come up, but it's going to actually say test number 1. It will tell you how much time you have, right? This sample test has been set for 30-minute time limit. And the test will be submitted automatically if you're not done in that time period. The sample test has 5 questions. In your test, I actually put the sample, or this test has whatever questions. And I'll tell you, question 1 is just the acknowledgement academic integrity policy. Question 1 is always this question. Question number 5 is, or the last question is always the file attachment. In between, your test will actually have 8 true, false, and multiple choice questions. This particular sample test has 1 true, false question, 1 multiple choice question, and then there's an example problem solving question, and where you enter your solutions. And then the last question is, again, always the file attachment problem. A few things about file attachment. I'm not being, like some of the faculty are having people take the tests during time, excuse me, during class time on Zoom with all their cameras on, asking for identification and everything. Others are just doing it through Blackboard and whatever. Some of us are being a little, we're trying to get some balance between giving the tests online. A lot of us are giving the tests online and we're asking for your work to be submitted, but your work must match, like the answers you get on paper, right? The work you did on paper, those answers have to match what you submitted in the questions in order to verify that you did the work within the time period of the test, and those are the answers you submitted. If for some reason, well, let's walk through this and you'll see. So let me click the sample test. And again, this is going to be similar to what you're going to see in a regular test. The regular test is also going to have this information about Blackboard support, technical support. The SUNY Help Desk is open Monday through Friday, 7 to midnight, and Saturday 10 to 8, Sunday 10 to 9. It tells you the test time, 30 minutes. It tells you it's going to be submitted automatically when the time expires. The test can be saved and resumed at any point until time is expired. This is the way the tests are set up. If you start a test, say I give you an hour test, at 1:00 p.m. you start it. And at 1:15, your dog comes and wants you to walk it. If you take the dog out for 10 minutes, and let's say you leave the test and you come back, you will have lost 10 minutes of test taking time. The timer does not stop. If you start the test at 1 p.m., it's going to, and it's an hour test, it's going to submit itself at 2 p.m. This test is 30 minutes. So as soon as you start it, it's going to, it doesn't matter if you leave and come back, the timer is going to continue. This particular test allows multiple attempts. So I let you go in and do this as many times as you want to walk through it. But your test will only have 1 attempt. And then you'll see something about the due date. I just made the due date of this test the end of the semester. That way you can go into it anytime you want to. Your test will have a due date and an end time. You cannot start past the date or the time. Now, you can start the test. So this one's due May 8th, 11:59 p.m. You'll be able to start the test at 11:55 p.m. And once you submit it, it'll just mark it late. But I wouldn't do that, because if you have any technical problems at all, first of all, I probably won't be up at midnight to respond to you. you won't be able to get back in and finish your test because it'll be after the start date. I don't actually know how it works with continuation past the due date. So don't take the chance. Start the test with plenty of time to finish it before the due date or the due time. So I'm going to start this test. And the first thing you notice is that you still get all the test information up here, which you can collapse. You have a timer bar, right? So it started timing already. You also have this question completion status. So notice here, if I click, I'm going to click agree for the, I'm certifying, basically I'm not giving or receiving assistance and I'm submitting my own work. I'm going to agree to this. And it's going to auto save if I don't save it. So just wait a minute here. So it saved it. And notice how this one grayed out. That means I've answered that question. Now I could jump ahead to question 3. I just threw some really quick, easy questions on here. The sum of the interior angles of a triangle is always, and so I'll put 180 degrees. I'll save my answer. And notice up here I can see, all right, I haven't finished number 2. I better go back and do that one. I can also navigate with the arrows. If you answer a question and you navigate away from it, it will save your answer. It should save your answer. Force is a vector quantity. True. So I'm going to navigate away from there. And notice it saved answer number 2. So if I go back to it, it's still saved. Let's go to question number 4. Question number 4. All right. So this is a fill in the response question. Determine the resultant of the force system shown. And I have a force system here, and this is right out of the examples from the chapters. So let's see. Do I actually have an answer to this one in front of me? I had it somewhere. All right. I don't remember the answer exactly. Let me see. I'm going to quickly find it. Mechanics, chapter 2. And notice what I'm asking for in the blanks. I'm asking for you to report to 3 significant figures. And the reason this is important is it's going to auto grade it based on, now, let me just back up here. When you submit this test, you're going to be able to see your results, but don't go by those results. These answers, I have to specify what the correct answer is in order to, make the problem, to complete the problem. So here, let's put 629 in, and notice this angle, right? You can't draw an angle sign in. So I'm asking you to report to the nearest 1/10 of a degree from the positive x-axis. Now, if you had a resultant that pointed this way, right, you would type in a negative, or you would type in a positive, whatever that is, right? So say it was 30 degrees below x, you would type in 330 degrees. Actually, you would do that because I'm asking you to report it as from the positive x-axis. So you're reporting it all the way around. I mean, I would accept a negative sign as well. It might not be marked correct. The real resultant here is 67.9. Now, let's say I didn't report 67.9. I reported 67.9213, right? I don't know what the exact answer was. So I'm going to save this. And then question 5 is just the upload. Here's where you need to follow the instructions, and you need to put into practice creating and uploading a PDF file. You're going to create a PDF file of your work. Your work should have your name. It should be legible. Scan things in order, right? Right side up. I don't want to have to be trying to rotate your PDF files, or, you know, look at your file and be like, okay, well, the last one's first and the first one's in the middle, and, you know, they're all out of order. You know, treat it like you're you're turning in an assignment. You want to make sure everything's in order. This is important. The answers on your paper must match the ones you entered into the question cell. So let's go back to number 4 here, right? If now, when I say they must match, right? If I put 200 in here and the answer is actually 629 newtons, right? If you put 629 newtons on your paper, but you answer 200, this is a red flag for me. I'm going to be like, okay, wait a minute, what's going on here? The work, it was the work done. You know, what's the problem? Because if you don't fill in this PDF on time and you email it to me, and all of a sudden the answers are different, right? I'm going to know that you took the time to actually do the problem, you know, find your mistakes. Now, if the answer is 629 and you wrote like 631 and it just happened to be that way because of rounding errors, right? It's going to get marked wrong by the computer, but I'm going to see the number. And this is what I'm looking for, right? If all your answers are correct, I'm going to look at your work and just make sure the work is done. If your answers are incorrect, I'm not going to just take the computer's word for it. I'm going to look at your answer and I'm going to see, okay, why is this, what did they put in there? Why is it incorrect? And, oh, if it's off by just like a couple digits or, you know, a couple newtons here, it's probably a rounding error. And I'm going to look at your work and I'll be like, oh yeah, it's just a rounding error. Or if, for example, you put in 62.9 newtons, right? I'm going to look at your work. I'll be like, whoa, what's going on here? And maybe you you multiply by, instead of multiplying by 10, you divide it by 10 somewhere, right? That's not how you do this problem, but just for example. And, you know, I'll deduct like a point or two for that, right? Depending on the problem, how many points it is. So, I mean, I will deduct for things like math errors and stuff, but if you don't turn any work in to me, I don't know what you're doing. And if you put a number like this in, 62.9, I'm just going to mark it all wrong, right? Because this is obviously not the answer. But if I see your work, I see, okay, this is wrong. If your work shows 629, you know, maybe you just, or maybe 620, 290, right? Maybe you just accidentally put the extra 0 in, right? Or you put some number in that doesn't belong. So I want to be able to see your work so I can give you partial credit for these solutions. So let's stick with the 629 here. Now, once you PDF your work and you save it to a file, you're going to have to upload it, right? So you're going to browse your computer, you're going to find the file, and you're going to attach it. So I don't know, I'll just attach one of these homework or the handouts. And then you're going to save and submit. Actually, before I do that, yeah, let's just do save and submit. This says you might get this message. The following question may be incomplete, number 5, right? Just double check, make sure you selected your file. Now, a few things I want to show you. I know when you started the test, and I know when you submitted the test, right? If for some reason you ran out of time and you didn't submit your PDF in time, right? Focus on doing the problems and answering the problems, figuring out the test. If you get to the end, and worst case scenario, you weren't able to submit your PDF in time, you just email it to me. Make sure in your subject you put something like TEC 120, test number 1 work. Don't send me an email without a subject or anything. It might not even occur to me that it's your test. And the timestamp should match, right? If you finish the test at 12:18 p.m., that email better get to me within a couple minutes, right? If your email gets to me like a couple hours later, well, I'm going to be very suspicious of the answers that are in your work, and I'm just going to scrutinize your test a lot more. So send it to me immediately. As soon as if you run out of time, just PDF it and send it. Now, you can also view the results. Be careful here. If you view the results, the multiple choice and true false ones, there's really no there's no argument about them, right? You either get them right or not, right? Select an answer, true. Select an answer, 180 degrees. These are correct. Now, this one here, notice the number of points you got, 10 out of 20 points. And this is because, I'll tell you why this is. You may have the right answers here. In fact, these are both the correct answers. However, in my solutions, I'm expecting an answer that's 3 significant figures. I'm expecting 67.9, I'm expecting 67.8, 68.0. I'm not expecting 67.9213. So if you answer this, you got it right. It's just that I need to go in and manually override the grade. And that's what I do when I look at the PDF file. I look at the work, I see, oh yeah, 67 point, I could actually, from here I could look and see, oh yeah, they got the right answer, they just didn't round, right? And I would just go in and mark this, I'd say, okay, that's 20 out of 20 points. The other thing is, this splits the answer evenly, right? 10 out of 20 points. This might be worth 15 points, and this might be worth 5 points. So don't look at this and think that's your grade, right? These points are usually going to go up, and they're almost always wrong because they don't account for any partial credit, and they don't account for the fact that you might have just typed the number in differently than what I had in the answer key. All right, so are there any questions about how the test works mechanistically? All right, so that's the sample test. Let me go back to the PowerPoint. That's the outline of the test. Like I said, 8 true false or multiple choice. I think it's actually like 3 true false or 4, maybe it's 3 true false and 5 multiple choice. I don't remember exactly. And those are, I'll tell you right now, those are right from your textbook or the slides that we covered. So if you know that material, the way I would prepare for this test, if I were you, I would have done the reading, right? So you know where things are in the textbook approximately. Because typically when you've done the reading, you're like, oh, you know what? That concept seems familiar. That's from chapter whatever, right? Chapter 1. Maybe even make an outline on your, know how to use your book, right? Your book has a chapter, it's got a table of contents, it's got an index. You can easily find things, right? For the working out the problems on paper, I'm telling you what you're going to need to know how to do, right? Solving triangles, determining moments, determining resultants. And in the next couple slides, I'm going to give you some more information, but you should know how to do this stuff, right? That comes from doing the homework and also working on the in-class or looking at the in-class problems. Have your homework available, right? This is open book, open notes. So whatever homework you have in front of you that you've turned in, you have that homework already. Fundamentals, right? You need to be able to solve forced triangles. There's no getting around this. Like this is the majority of the class. If you do not know how to use law of sine, cosine, or the Pythagorean theorem, or understand how to apply sine, cosine, and tangent, you will not do well. You need to know that. You need to practice it. You need to get used to it. And then setting up and solving algebraic equations. Not so much, the algebraic equations, very simple stuff for this first test. I will take points off of this. This is the one thing that stood out for me on homework 2 that was a disaster. So many people turned in the homework and they just reported forces, or they reported a direction without any type of, they reported an angle without any type of reference. 5 degrees from what? 5 degrees from the horizontal x-axis, 5 degrees from the vertical x-axis or the vertical y-axis? I don't know, right? I need to understand what direction you think this force is going. I know the answer. I can look at it and figure out the answer. Put a direction vector in, right? Put an arrow. Put a little angle symbol, right? You have to have a magnitude. You have to have units, right? If you're calculating forces, their units should have newtons or pounds. Kilograms is not a force. I cannot tell you how many people on that one homework problem where you're given a mass of something forgot to multiply by gravity. If you're given something in kilograms, you multiply it by the acceleration of gravity. And that's where you get force of newtons. Kilograms is not a force. Don't label anything a force with kilograms. You're at an advantage in this test because the fill in the blank problems, I usually provide the unit for you. So you need to, it's going to be very easy. Just look at the unit I'm requesting and fill in the blank with the correct number. Transmissibility. That's basically the principle of how you can, let's see, do I have a, oh no, I didn't put the transmissibility, right? Go through all the stuff, all the chapters 1, 2, and 3 materials available to you. You have the PowerPoints available to you. You have the textbook. I mean, the PowerPoints are basically a summary of the textbook. The textbook has all the detail in it, right? Transmissibility is where the force can act anywhere along its line of action, right? And still be treated the same. Force and vector manipulation. Basically, knowing how to do all this stuff. Take a force and resolve it into components, X and Y usually. Adding components to get a resultant, right? Maybe you've got 2 forces that you've broken down into components, and now you're adding those components together, and now you've got an X and a Y, and now you can get a new resultant, right? A single resultant. And then how to find and report the correct direction of a force. So we're going to go through some of this stuff, and in particular, I'm going to go through some of the chapter 2 problems that I thought were particularly difficult. Moments. Moments are given about a point, right? You say the moment about a point. And what is that? That's I put in these little subscripts. So for example, the moment about point A is the force times the perpendicular distance from the line of action of that force to that point. Notice it's a perpendicular distance. Important thing about moments is to keep track of your signs, keep track of your directions, right? Counterclockwise is a positive, right? That's the notation we use. And clockwise is negative. So those are the sign conventions. I mean, you could use the opposite sign convention and get the correct answer as long as you do the bookkeeping, right? Be consistent with your directions. If you always just use counterclockwise as positive and clockwise as negative and never switch them, right? You'll be fine remembering that. And then follow your sign conventions, right? Add counterclockwise moments, subtract clockwise moments, and you'll get the correct moment. And if the answer is negative, it's clockwise. If the answer is positive, it's counterclockwise. Couples, we covered couples. Equal and opposite forces, right? Separated by a perpendicular distance. So just think of married couples, right? You want the relationship to be equal, but typically opposites marry. and maybe later they wind up getting separated by a perpendicular distance. All right. These are problems you should review. Chapter 1 in the handout, I narrowed it down. I didn't want to give you like specifically one problem and say, yeah, do this, it'll be on the test. Examples 7 through 12, you should know how to do all those. Those cover mainly the triangles. Chapter 2, examples 2 and 4, those are forces. And again, taking in, one of those has 3 forces in it, the other one has 2, I believe. And then chapter 3, we did some of those examples. Oh, we did all those examples. Those are moment couples. Homework problems. If you did not understand a homework problem, see the solution key. Where's the solution key? It's in the homework now. So after I grade the homework, I put up the solution key. Let's go see what that looks like. Module 1. Homework number 1. If you haven't noticed already, when I grade a homework, I put in a little note. Homework's graded on 131.21. Solutions are attached. And I tell you approximately how I graded. 5 points each for completion, 5 points each for accuracy. So basically, as long as you did the problem, you got 5 points for it. If you did it correctly, you got the other 5 points. If you were wrong, right, it depends on how wrong you were. And these are the answers. Now, the handwriting does have some issues, right? My handwriting could be better. I did my best here when I tried to put this up. Let's see. But all the homework problems are here, and I walk through them. Now, the thing about some of these geometric problems is you can do them more than one way, right? So if you did it the same, if you got the same answer and did it a different way, it's kind of helpful to actually look and see what's the other way you do this, right? How does this compare to what, what I did? How are the two methods similar? So go ahead and look at these answers. Chapter 2, I want to check, since I'm here, I want to check that I made a note. Module 2. Oh, yeah, right. The questions were up here. So the answers are posted. Let's see. Oh, yeah. Number 7 should be 1.52 kilonewtons, not 15.2. In my answers, I made a mistake. I just forgot to carry over the, let's see, number 7. Yeah, so it's 1520.7 newtons. I wrote 15.2 kilonewtons. I forgot to move the decimal point. It's 1.52 kilonewtons. That's why I made the note. And I noticed that obviously right away when I looked at someone's homework problem and they had 1.52 kilonewtons, and I was like, what? I said, oh yeah, I made a mistake. So those are all here. Those are the answers. What is this? This is a cross out. Ignore that. I redid it here. Yeah, some people did exactly what I did. They did number 17B. Do the problem that you're asked to do, 19. The figures in your book can get a little crowded. So let's walk through. Let's see, that's homework 2. Oh, and for homework 2, they all didn't count the same. First, I gave about 40 points for just, if you did them all, it was 40 points. So that turned out to be like 3.3 points per problem. And then, depending on the problem, I gave more points for like 13 and 32, which were a lot more involved than the other ones. So 23 and 22 were also more involved. And then the rest were 5 points. Oh, sorry, the rest were 3 points. And what I want to do here is go over some of the homework problems. Are there any questions about anything so far? Okay, this homework problem appeared to give a lot of people trouble, so I want to review it. I basically picked the 3 hardest problems, the ones that people got the worst grades on. So I looked at the averages the average grades of each of these problems. And this was one of the winners or losers. We've got two tow trucks pulling a car from a ditch, right? And the tow trucks are labeled A and B. And we know the distances they are from the cars, wherever they're hitching the car from. Now, I have no idea if you'd even try this in real life. But you got this car and you've got one tow truck here and another tow truck here, and truck A is a force of 8 kilonewtons, right? So what's going on with the force? The force is being exerted right along this line, right? Right along this chain. I'm assuming it's a chain. Truck B is 6.5 kilonewtons, right? So you have a force triangle here, and you're given distances away from. This is the point that all the forces are acting on, and these are the dimensional, the chains, right? The forces acting along this chain. So we've got triangles that we can break down and figure out forces for. So let's see how this is done. First of all, I made a very, very, very rough sketch. And I want you to see what this looks like. Some people made angles. You can do that. It takes a little more time. But we've got basically two forces, force A and force B. So what we want to do is I want to break the forces down into components, right? Add the components. And these components are going to be X and Y, right? Then I'm going to construct a resultant. Ran out of room. All right. What I want to do here is I want to first draw out these triangles or these forces for you. I've got force B here, and force B consists of an X component and a Y component. And I'll also draw force A here. All right. Now, I want to start with B here. I'm given some dimensions, right? I'm given, first of all, I know the length is, I know this is 10 meters in height, right? This is 10 meters. And this is, I'm going to call this BY for the force. Now, I know my force B is 6.5 kilonewtons. And this is going to be BX. And this is 25 meters. Right, I want you to see I've got a force triangle and I've got a dimensional physical triangle, right? I'm not given the length of this hypotenuse, but I can calculate it, right? The length here, let's call this, I'll call it H sub B for hypotenuse of B. Right, let's do the math. Well, I'm running out of room here. Let's do it at the bottom. H of B. This is the Pythagorean theorem, right? This is a right triangle. Let me just make a little right angle in here. It's going to be the square root of 10 squared plus 25 squared. And this is going to give me oh, good, it is 26.93 meters. Now I'm rounding. It actually goes on and on. This is the B hypotenuse. I'm going to write this in up here, 26.93, right? And I know the force. Let's do the same thing for A. A is 8 kilonewtons. The lengths I have are 25 meters on the bottom here still. And this is the A or the X component of the force A, right? This red is the force, the X component of force, and the vertical is the Y component of force. It's AY. The vertical height is 30 meters, right? So my hypotenuse of A is going to be the square root of the sum of the squares. I've got 30 squared plus 25 squared. This is going to give me 30 squared plus 25 squared. 39.05 meters. All right, so this is the length. So you have all the information. This is exciting, right? You've got you've got the force along this hypotenuse, and you know the force triangle is similar to the geometric triangle, right? And you have the lengths of all the sides of the triangles. So we can break this down into X and Y components by using the ratios of the lengths of those triangles. So let's do that. Let's make a table here. My first column is going to be the force in kilonewtons. Oh, you know what? I'll just do it A and B. Let's do truck. Truck A and truck B. And then we're going to have the X component. And that's going to be in kilonewtons. These are technically forces as well. Well, what do we got for A? I might as well combine them. This is 8 kilonewtons. And B is exerting 6.5 kilonewtons, right? Those are our hypotenuse of the force triangle. So here we're looking for forces. What's the X component of force for A? Well, let's look at our triangle. And I'll make another column here, Y component. And let me do all the X components first. So we'll start with A. We've got a ratio here, right? We know the force is 8 kilonewtons along the hypotenuse, but we don't know AX. But we know the lengths, right? So we could say, I'm going to write we could take the force, 8 kilonewtons, and multiply by the ratio of this side to the hypotenuse, right? It's like we're taking the force and we're saying, all right, the fraction of this force, or this force is the same fraction as the length is of the hypotenuse, right? The same length to length ratio. So 39.05. This gives us, oh yeah, the other thing we want to look at is direction. You have to do this manually. There's no way around this. You have to look at this and say, oh, this is pointing to the left. How am I going to designate that? Well, my axes are going to be positive in these directions, positive X, positive Y. So I'm going to make this a negative, right? That's my negative component. And this turns out to be 5.12. Negative 5.12. So this negative reminds us that the thing is pointing to the left. Let's do the X component of B. So now B also has a negative component, right? It's pointing to the left. And again, we know the direction because we know the direction of the vector, right? The vector itself is pointing up and to the left. So that means the X component has to be to the left because it has to go tip to tail with the vectors, right? You have to have a component in the X direction that's to the left. The right just doesn't make any sense, right? And it has to be also up to the top when you're doing the Y. So anyway, this is a negative. We've got 6.5 kilonewtons times the ratio again, 25 to 26.93. And this is going to give us negative 6.03. Now we do the Y components. The Y components are just taking the same. So now the Y components are both positive, right? That's pretty straightforward. Our Y direction's positive going up. So we're going to start with 8 kilonewtons times the ratio. What's the ratio of the triangle lengths, right? The proportion, this length is the proportion relative to the hypotenuse is 30 divided by 39.05, right? That means that the force, the ratio of the force to the hypotenuse is the same thing. So we've got 30 divided by 39.05. Now, you can also tell you're making a mistake if you wind up with a force that's greater than the resultant, right? I should have a number less than 8 for the Y component. So this turns out to be what, 6.14. And down here, now if I had inverted these, if I had taken the wrong ratio, I would have gotten 8 divided by, or well, 8 times 39.05 divided by 30, right? I would have gotten 10.4, which is obviously, again, this is part of what your problem solving skills are, is recognizing when things make sense or not, right? You can't have a force in the X or Y direction greater than the resultant, right? The two smaller forces add up to create the bigger force. Let's see. Now, that's for this geometry, right? You can have other geometries where the resultant is less than, it's particularly if they're going in opposite directions. So this one here is 6 times 10 over 26.93, right? Because our Y height is 10, and this gives us a number of 2.41. So now I'm going to add these up. Let's get through this real quick here. The resultant of the X components, right? The total X component force is the sum of these, right? And in this case, we've got 2 trucks acting together in the X direction, the negative X direction. So this is a negative 11.15. And in the Y direction, we've got a resultant in the Y direction as a positive 8.55. So I'm going to draw this out. I've got negative 11.15. Oh, let's put some units on this, kilonewtons. That means I have an x vector that looks like this. This is 11.15 kilonewtons. I've got a y vector that looks like this. 8.55 kilonewtons. I have a resultant that's the sum of those, r. And I have an angle theta. Now, if I'm asked to report the force, the resultant, right? The resultant is both a magnitude and a direction. The resultant is relatively easy. I think a lot of people got this. 11.15, and even if they didn't get the right numbers, they knew how to do this. 8.55 kilonewtons squared. This turned out to be a resultant of 14.05. Now, the angle, this is where people really had trouble. Theta is the inverse tangent, right? Tangent is opposite over adjacent. Is the inverse tangent of opposite over adjacent, 8.55 divided by 11.15. This gives me a theta of 37.48 degrees. When you report this, the resultant is 14.1 kilonewtons, I'm just rounding here, at an angle of, notice my direction, 37.5 degrees. I could also report this as R is 14.1 kilonewtons. And if I'm reporting the angle off of the positive x direction, right, I would use a sign like this, and it would be 180 minus 37.5. So this would be 142.5 degrees, right? What is this telling us? This is telling us, depending on how I reported it, these are the same thing. I'm saying I'm pulling 14.1 kilonewtons worth of force at 37.5 degrees off of the left-facing horizontal axis, right? This one's telling me I'm pulling 14.1 kilonewtons at 142.5 degrees off of the right-facing x-axis, which means I got to rotate all the way around until I'm like this, right? Which is basically 180 minus 142, which gives you the 37.5. All right, so I'm going to end here. And are there any questions in particular about this problem? And if not, feel free to exit the meeting. I'll cover more on, what is today, Wednesday?